Okay, so we can see how the ML pipeline can be implemented. Okay, the build phase consists of 5 modules. That is the data ingestion step, data model training step, model testing step, model packaging step, model registration step. Right. So we can see them one by one using this example. Okay, first is the data ingestion and feature engineering. Okay, so ingestion means you have to extract data from various sources. Here you are extracting the data from the feature store. Okay, yeah, the feature store holds the pre-processed data. Okay, so you will import the pre-processed data for the machine learning training. So then only you can perform machine learning training and testing, okay, for a particular project. So for obtaining this, you have to import the pre-processed weather data set. Okay, our data set is a weather data set. So you have to set the workspace. Okay, workspace with subscriber ID, group name, then workspace name. Okay, okay, can you understand? It is given in the below code. Then what you have to do is you have to import the pre-processed data set. What pre-processed? You have done a pre-processing by eliminating or cleansing or normalizing. Okay, you have eliminated the unwanted empty uh, empty data. Okay, and you have deleted some of the rows missing values. Okay, then that is the pre-processed data set. So you are just loading the pre-processed data set from the repo, okay, or the workspace. Okay, in order to do the machine learning, okay, you have to load it, okay, or import your data set. So the function used is get by name, okay, that is dataset equal to dataset dot get by name of workspace. You have to mention name of the file. Okay, yeah? Name of the file is processed weather data port of Turku. Okay, yeah? Port of Turku is a location. Okay, in Finland. Okay, it is the port area. The weather data set belongs to that region. Okay, so this is the data set. Okay, so it consists of timestamp, location, temperature, okay, then humidity, wind speed, wind bearing degree, visibility, and pressure, then current weather, future weather. What you have to do, what you have to predict, what is the outcome, what is the output? Future weather, okay, you have to predict the future weather, whether it will rain. We use all these features for the training, okay. So before training, what we have to do? This is we are at the ingestion step only. Okay, ingestion step. We have to split the data. Okay, it is all about data. We have to do the data engineering. Okay, so the splitting the data for training and validation sets. So this is the feature engineering. Okay, so feature engineering is nothing but selecting specific features alone. Okay, there are more columns. Okay, yeah. Uh, So from this, only few of the columns can be subselected. Okay, it is similar to what we do in database operation. Okay, so this is selecting and scaling features. Scaling means adding extra features, and scaling the features means we have to append extra features. Okay, so for not for training, we can do both options. Okay, based upon our necessity of the project, we have. So why we want to split is because ML algorithm use these variables, okay, in order to learn. So based upon the variable structure of the machine learning, we are what segregating the data into separate what label and input data like that. Can you understand? So this then next is the scaling the data. Scaling the data is somewhat pre-processing steps only. Here we are transforming some of the data and we can add data, okay, also. Okay, so such things can be done. So next is the machine learning training. Machine learning training, you know, right? Here up to this is ingestion. Okay, this is model training. Next, okay, we are going to see about model machine learning training. So here, what is the thing? We are going to use the prepared data, that is the testing data. Okay, we need to train it, okay, using our SVM algorithm and random forest algorithm. Okay, there are two machine learning algorithm, support vector machine algorithm, then random forest algorithm. Okay, these are two classifiers. So by using this, what we have to, predict the weather, future weather. Am I right? So first step is initiate. We have to initiate the experiment by using my experiment. This is just like creating a project. Okay, you have to create a training environment. Okay, yeah, for your, so that you have to, okay, put an experiment name, my experiment, or any, okay, SVM experiment. You can put anything. Okay, so then you have to do the training sets. Okay, the training consists of, okay, hyperparameter tuning. Okay, hyperparameter tuning and training. Okay, yeah, here the hyperparameter tuning or this parameters. Okay, parameters to tune. Kernel is linear and RBF you are using. Okay, you can, we can use linear alone, we can use RBF alone, and we are using both together here. And C is also one of the parameter for tuning. If we increase or decrease the values, we can improve the performance. Okay, learning performance. So only these parameters are available. So then we are training the model with best parameters. Okay, just here we are setting the parameters, setting the option for learning. Okay, yeah. Then next here, what we are doing here, okay, here we are doing the what, learning. Okay, here we are doing the learning. SVC equal to SVC of C equal to grid dot get params deep equal to true estimator. Okay, these are the parameters. Okay, for SVM. So this, the function name is SVC. Okay, yeah, support vector classifier, like that they have given maybe. Okay, so what are the data we are inputting? This is the third thing, right? ML testing step in ML pipeline. So we can see it. So model testing and defining metrics. Okay, one of the main thing if you done here is model testing and defining metrics. We have to define all the metrics: accuracy, precision, recall, F score. Okay, so accuracy is correct predictions by total predictions. Okay, yeah. Correctly classified positive samples and correctly classified negative samples divided by total number of all samples. Okay, that is accuracy. In order to find the accuracy, this is the formula. Similarly, precision, true positives. Okay, yeah, by true positives plus false positives. Similarly, recall is true positives by true positives plus false negatives. Similarly, the F score also. So this is the testing. Okay, testing the SVM classifier. Testing, you have to write the code. Okay, this code is, you are using the metrics from the sklearn package. Okay, sklearn package, you are using the metrics called accuracy. Okay, you are importing the metrics such as accuracy score, F1 score, precision score, recall score, because these all are functions. Okay, in the sklearn package. Okay, so when you want to use this function in order to calculate, you have to import this. Okay. So SVC is the learned SVM training data. Okay. After learning, this SVC only contains the all the learned data. So now you are using this SVC to predict the what, test data, test input data, and you have to get the Y test. You have to get the Y test. Okay, you are using only the X test. Okay, so here you have what, predicted. Okay, and the predicted SVC is here. Okay, and using this uh, white test and predicted SVC, you are comparing. Okay, original white test has the original data. Okay, yeah? Original predicted data, original data, and the predicted. Now the after the predicted data, how much it is predicted correctly. How many positive instances have been predicted as positive? How many negative instances as predicted as negative will be in the predicted SVC. Okay, and how many of them are predicted as false positives and false negatives are in the predicted SVC. Okay, so using this we can calculate the accuracy. Can you understand? Similarly, other measures also there. Okay, you can, you have seen, right? Yes, so this is the output of the SVM. So here accuracy is 0.95. That is, many of the positive true samples has been what predicted as true. Okay, and false. Okay, another negative samples been predicted as true. Okay, only 5% of error. Okay, and the last step is registering the model. Registering the model is nothing but we want to convert it into small chunks of model. Okay, yeah. In order for I'm packaging the model. Okay, we are just converting the model into flexible for online, okay, evaluation, online testing, online training. We are just converting the full project into data set into small modules like structure. Okay, so model registration has to be serially stored. Okay, every model has to be serially stored in the model registry. Okay, using some logical container you have to store. Okay, then you have to store this registered model. Okay, then only you can deploy it. Okay, why not deploy, only you have to convert the models into serialize and store in a model registry. Okay, you have to store in the model registry. Okay, a logical container has to be used. Okay, in order to store these files. Can you understand? So we are registering the support vector machine. So in order to register the support vector machine, these four things has to be done. Okay, a model registration. Okay, you have to register in Azure ML workspace. Okay, yeah. So you have to do it in Azure or ML workspace with the specific names. Okay, then you have to tag the metadata. Okay, then the model framework. Okay, you have to model is associated with the pandas framework. Okay, okay, these are frameworks. Okay, you are converting into framework, then we are verifying it. Can you understand? Is using from Azure ML dot core import model, you are using importing the model. Okay, then what you are doing, you are registering. Okay, model dot register, then model underscore path, you are, okay, you are putting the output registered, okay, file as svc.onyx. Okay, then you are put specifying the model name. Support vector classifier is your model name. Then you are setting the various hyperparameter setting in the tag location. Okay, then model framework, you are using pandas. Okay, pandas and its version. Similarly, you are specifying the workspace with description also. Can you understand this? How we are registering the model? Here, everything we have to register. Okay, data we have to register. We have to register our training set, test set, everything you have to register after. Okay, so here this is for training and testing we have seen. Okay, and then this is the registration. Okay, so registration, we are registering the model. Okay, so this is the output. Okay, after registration this will be generated. Okay, so that you have identified two model. Okay, version 1 having version 1. Okay, random forest version 1 for your weather prediction, then support vector model for the weather prediction. Both version 1 you have now generated. Okay, can you understand now? This is the ultimate PPT. Okay, I have executed the codings. Okay, some of the codings I have executed. Okay, let me see if I can illustrate to you. Okay, this is the full coding actually. Same thing what I said in the PPT is given here. Okay. Can you able to see it? This is where I got the output and all. Okay, after pre-processing. Okay, then